All right, hello everybody. Welcome to my talk. Thanks for staying so late in the day and coming and seeing this talk. Um, we've got lots of interesting things to talk about, so let me get right into it. So, software is eating the world. Pretty much all the biggest companies in the world are software companies now. If you go through almost every business, it's now a software business, even if they maybe don't realize it yet. So, selling books, Amazon, hotels, Airbnb, transportation, Uber. Even car manufacturers spend a lot of their time writing software these days. Self-driving cars, anti-lock brakes, navigation systems, management systems. You go through almost every industry these days, and everything's kind of software now, which as software developers is awesome. It's totally awesome. I remember a couple of decades ago being worried we might run out of things to write. Like it felt like things were getting too simple, and we might not need so many programmers. It's actually exploding now, right? With big data, artificial intelligence, the web, mobile, Internet of Things, social media. We just need more and more software all the time, which is awesome for us in the room, right? That's really, really good. But the challenge is for a lot of businesses, and kind of like this quote, it is not necessary to change. Survival is not mandatory. In other words, increasingly businesses are being disrupted by new startups, particularly, who have figured out how to do software well, how to deliver software value quickly, and how to how to give really good user experiences quickly. A lot of companies have never really quite figured out how to do software very well, right? A lot of industries or a lot of companies can be a little bit kind of slow, right? So all of us really now need to really try and speed up and up our game to avoid being Uberized, right? So I hope today's talk I'm going to show you how you can all go really, really fast, right? And deliver business value well. Now, software is really hard. It's really easy to write software, but it's really hard to write software that delivers real business value, right? Any programmer can sit there with a compiler and a keyboard and write something. The problem is it might not be the right thing your business needs to add real business value, right? And one of the worst things you can do is ask your users what they want. Do you remember when the iPhone came out? Everybody wanted a flip-down hardware keyboard. We all wanted styluses. We wanted memory card plugins and all this kind of stuff. And then Apple came out with just this flat touchscreen thing, and we all kind of went, ooh, that's nice. So really, customers don't really know what they want, but they do know what they don't want. And when they see something they like, they like it. So the only real way of doing software well these days is just iterating quickly, right? Don't sit in your ivory tower for a year writing requirements documentation and then spend a year writing something and then 6 months delivering it. Get something out the door as quickly as you can in front of users and get them playing with it, trying it with it, using it. Increasingly now to develop software well, we need to do experiment-based and A/B testing and get feedback, right? So the best way we've figured out to write software and deliver real business value is through these various continuous improvement cycles. So continuous integration. I think a lot of people have been doing continuous integration for a while. How many people use continuous integration today? Okay, that's a good number. That's half the room, say. So that's one way of continuously integrating our code to check we haven't broken it yet. And we keep building it, and it's still working, that's good, that's happy. Then we can move on to continuous delivery of continuously moving that software from development to testing to staging to production. Then there's continuous operations, and then continuous management and feedback. So we have lots of these virtuous feedback cycles where we're continuously doing everything more and more and more, and we're getting continuous feedback, so we're getting better all the time. Right? So this is a way that we can all keep iterating quickly and get better at developing, testing, releasing, staging, and ultimately running and managing our software. Now, the ideal way of doing this kind of continuous improvement these days that we've figured out is continuous delivery of containerized microservices. So you've probably heard quite a lot about Docker already. Say microservices one more time. So you've probably heard microservices more than once this week. For me, really, microservices is just a technique to go fast, right? And there's two real parts to it. One of it's technical. So pretty much every system I've ever seen, like if you ask someone, if you join a new team and you say, what's the system? They'll draw on a whiteboard lots of rectangles and they'll name them all with crazy, interesting, sometimes comical names. And they'll say, this is the system, it's all these boxes. And if you're building a monolith, you release everything on the board together. So you all agree when you're going to release and you all check everything's okay. And then you all release everything together, and depending on the size of your monolith, it can take possibly weeks or months to do a release, right? It's complicated. You often have large teams. There's lots of discussions and meetings and planning, and it's complicated, right? The microservices version of that is every rectangle is its own release stream. So each rectangle gets released independently of all the others, which means you can go faster because you're not waiting. You're not saying, well, I'll release when that other team's done his bit. And when that thing's ready, I'll release with that thing. Each rectangle releases independently, so each rectangle can move at its own pace. Some of these rectangles, these microservices, might be releasing every hour. Other ones might do once a year because it kind of works and you just have to fix it now and again. So it lets you move at the right rate for the different parts of the system and lets you iterate really, really quickly. So part of microservices for me is just you release independently, which adds complexity, yes. It makes everything much more complicated, but it makes everything much quicker, right? If you're doing a monolith, the Mythical Man Month said years ago, the more people you add to a team, the slower it gets. So if you're working on one massive monolith, and you just add more and more people, you have more and more meetings, it takes longer to decide anything, it takes longer to test anything. So you gradually get slower and slower and slower. Where microservices goes, you generally get faster as you add people because you tend to make more microservices in parallel. And over time, you get better and better at doing the releases because you're doing them all the time. So part of it is decomposing your system into microservices and releasing them separately. The other part is social. Lots of companies have silos. So you have a testing silo and an business analyst silo and a developer silo and maybe an operations silo. And everybody does their little bit and then throws stuff over the wall for the poor person next door who does the next bit, which is one approach, okay? And whereas the microservice approach is rather than having vertical silos, have horizontal teams. For each microservice, have one team that does design, testing, development, and runtime operations, right? So I've been in open source for quite a while, and I found that just working in open source, developers tend to put a little bit of extra care into their code, right? When your code is going to be on the public internet forever, that your future employer could Google your code, you tend to kind of take out the swear words and the kind of really crappy bits, or most people do. I probably don't so much, but other people do, right? And if you're the person who's writing some code and you're the person who's running it in production, you tend to make things a little bit easier to manage, right? You tend to make the software a little bit easier to reason about, easier to stop and start. You tend to put more metrics in there. You tend to put better logs. So when it's in production, you understand it. Because you're writing the code and you're running it, you tend to think about production first, right? If we want to go fast, we have to be thinking of production first and everything else follows from that. Rather than, I'm hacking on my laptop, I don't really care about production, I'm chucking it over a wall and then it's someone else's problem, right? We should be developing for production all the time. Not using Windows or a Mac to run your stuff. You should be running everything in a Docker container in a production-like environment, right? So that's really microservices. It's two things: split things into pieces, and then each team, and then have a team aligned around those pieces, and then those teams can just release independently, right? For me, microservices is a little bit like concurrent programming, right? We're taking out all the mutexes everywhere. So we've got lots of threads that are non-blocking. Each team and each microservice is a thread that can just go as quick or fast as it likes and release whenever it wants. There's no coordination or meetings or scheduling, right? You can go as quick as you like. So this is how we should be delivering software these days. If you want to go fast, if you want to be competitive, if you want to deliver business value, microservices looks like the best approach. So that's kind of cool, but we now have some issues, right? If you're just working on a monolith, life's kind of easy, right? You've got one Git repository. You release every year, maybe twice a year. It maybe takes you a few days to do it, and it doesn't really matter. And you maybe use shell scripts and vi and all sorts of stuff to do releases, and that's okay too. But as soon as you move from one monolith to, say, 10 microservices, 100 microservices, maybe 1,000 microservices, and then each one's releasing every hour, that's a lot of releases. That's a lot of projects to start up. That's a lot of builds to do. That's a lot of stages to do. And you can't really even start to go down the Microsoft Freudian slip, down the microservices world unless you've automated everything, right? It's almost like you should really automate it first before you start doing all of this. Otherwise, you spend all of your time just doing releases. And really, the point of this is to go fast. So figure out your automation first before you have this microservice explosion. One thing we found, so I've I work on a team at Red Hat, and we started off with a monolith, and we've gradually moved towards microservices. And we've just had an explosion of microservices now. We have tons of Git repositories and tons of releases. And it's extremely painful if you don't do your automation up front. A lot of companies, like the Netflixes of this world, and lots of other companies like Guilt and so forth, they have nearly 1,000 microservices, right? And they're growing all the time. So the more you invest up front on your microservice journey with automation, the better, because it will just save you huge amounts of time and effort later. So we need to optimize all the things. What we really want is a simple open source developer platform that developer teams can just spin up microservices whenever they want, using whatever their technology flavors that they wish to use are, and it automatically does system testing, load testing, soak testing, staging, production, monitoring, metrics, and feedback, right? We just want a thing that just does all of this, and then we can focus on the programming part and actually making the software. And all this other mechanics can just kind of happen, right? So I'd like to kind of show you one of those. So I've been working on this open source project at Red Hat called Fabricate for a while. So Fabricate as in to make. So Fabricate microservices, but it's with an 8. Because it's a shorter URL, basically. It's fabricate.io. And it's basically a whole bunch of open source software that tries to help developers be productive on the modern technologies that we tend to use today. So what does it do? It really has wizards to help you create new microservices projects, whether that's Java, say, with Spring Boot, with Tomcat, with Wildfly Swarm, with Vertex, or with Node.js, or with Golang, or with Swift, or with PHP even, or whatever you want to use, right? Pretty much every language is supported. We have automatic ways of building your software into Docker images, which are all versioned, and that immutable Docker image then moves through testing, staging, and production. So you automate the migration of the code through the pipeline. So you're not manually changing things to go from testing to production. It just kind of happens automatically, right? Then we have a whole bunch of stuff that does rolling upgrades, right? Once you're in production, you need a new version, and you want to do a rolling upgrade of the new version to replace the old version, and possibly roll back if things are quite bad. So you can roll forward and roll back whenever you wish. There's also a whole set of management stuff you need to do, like centralized logging and management that we'll talk about later for metrics or logging, because otherwise you've released something to production. If you've no idea what it's doing, you probably shouldn't go to production, right? You need to know what are the logs for every container, what are the metrics for every container, what's happening, are you getting more errors now than the previous version? You need this feedback so you can make informed decisions, right? As soon as we go down this microservices journey, it's fun and it's awesome and you tend to go really fast, but it can be kind of tricky to understand what's going on, right? So we need tooling and software to help us understand what's happening and get feedback so we can react, right? We can react if there's an issue or a bug or whatever. Finally, the platform. Lots of different customers have different legal requirements or technology requirements of whether they use the public cloud, are you using your own data centers, are you using a partner's data center and so forth. So we can't just assume it's just Amazon or anything. So we need a platform that runs on your laptop. It runs on Google or Amazon or Azure or DigitalOcean, or it can run on-premise on any hardware you have. So that's pretty key. So everything in Fabricate is completely open source. You can download it and play around with it right now. I'm not going to tell you how to download it right now until I've done my demo in case the Wi-Fi goes screwed. But now I'm going to demonstrate Fabricate for you. I think it's easier for me just to show you it, then you can see what it does, and then afterwards I'll walk through how it does what it does, and what are some of the open source technologies behind the covers that you can kind of play with and look at. So let's fabricate some microservices. So I've already installed Fabricate. I'll show you how to do that later. This is all running just on my laptop. So everything is on my laptop, so it's not the speediest thing in the world. Normally I would suggest you have a couple of computers that you run this on that's not your laptop. You don't want somebody to close their laptop lid and then all the bills stop and production ends. So you probably want a real cluster in the real world. But for now, I'll use my laptop. So this is the home page of the Fabricate web console. It's AngularJS. It's using TypeScript and AngularJS to talk to the Kubernetes REST API, which I'll talk about later. First thing I'm going to show you is just the runtime in my teams. Each team have their own environments. And I'm looking at the runtime in the development environment, and this is where all the development tools live. Let me just make this a little bit bigger. So these are the out-of-the-box development tools and runtime tools that come with Fabricate. So Fabricate is a one-click install, and all this stuff just works. You don't have to configure it. Out of the box, we use Jenkins. You see Jenkins there. We've got one container of Jenkins running. We have Nexus. So Jenkins is for CI and CD. Nexus is for an artifact repository. So it's where all your releases go. So when you do a release, your jars and wars and POMs and all those kind of things will be in Nexus. We also use Nexus as a proxy. If you're running this in the public cloud, you don't really want to be downloading the internet with Maven builds every build. You just want to download the internet once and keep it on your cloud. So we use Nexus as this proxy that stores all the Maven artifacts over time, so you never download it twice. We also use persistent disk in builds, so once you've downloaded it into your build, you don't download it again to take the load off Nexus. If you're an open source company, you probably put everything public and on GitHub, which is cool. If you're an enterprise, though, you might not be able to put everything on GitHub public. So you probably want an on-premise Git hosting provider. There's a bunch of these. You might want to use GitHub Enterprise. You might use Atlassian Slack. We bundle open source implementations of Git hosting out of the box for you. So at least you've got a Git repository to start with. You can work with any Git repository, though, you like. So we ship with this thing called Gogs. You see the thing above Jenkins? Gogs is a small Golang-based Git server that's kind of like GitHub, but it's open source. There's also this thing, Fabricate Forge, which I'll show you later. That's a thing that's based on a tool called JBoss Forge, which is a tool for wizards to help developers do things. And we'll see that in action in a moment. So that's the guts of what I'm running right now. Let me look at the team dashboard. I created a little malarkey microservice just in case my demo went pear-shaped. But I'm going to create a real project now, and hopefully that will work. So I'm going to click the Create App. You've now got two choices. You might already have created a Java app and there's a Git repository somewhere that you want to import. But I'm going to assume we're all now a team. As microservice teams go, two pizzas wouldn't kind of stretch this far. But just imagine we're all a microservice team and we're all about to write a microservice together. So we kind of go, okay, we're in our team. We hit the create button. And now we get a little wizard up of all these different kind of wizardy things we can make. So if ever you've used spring.start.spring.io, we've got that kind of wizard for Spring apps where you can choose all the modules you want to use. We've got a similar thing for Wildfly Swarm. We've got a whole bunch of archetypes for things like Apache Camel and CXF and all the Java EE stuff. In this case, I'm just going to create a vanilla microservice, which is really just a standalone Spring Boot Web MVC microservice. So I'm going to create that one, and I'm going to call it DevOps Awesome. No, cool. DevOps Cool. DevOps Cool. Yeah, that's not a bad name. Not too long. Okay, then we click the Create button. What it's doing under the covers now is it's going to generate the source code for whatever wizard we picked. So if it's a Maven archetype, it would generate the archetype onto disk, substitute in the organization ID and the version and all that kind of malarkey. Then it's going to create a Git repository. It's going to check the code into the Git repository and push the Git repository into the Git repository, into the Git hosting server. Now it's giving us a list of pipelines to choose from. Now I'll talk about pipelines a little bit later, but these are a thing that's part of Jenkins 2 that helps you define your continuous delivery pipeline. So think of it as a bit like workflow for CD. It's a thing that has all these steps that you build your code, you build your code, you generate your Docker image, you push the image to a Docker registry, you run a system test in the testing environment, you stage it to the staging environment, there's a human approval step, and then we go to production. So pipeline defines all of these steps. You can have sequential pipelines, you can have parallel parts, you can wait for things, you can do fork and join, all that kind of stuff. Now, not that many people right now know how to write these things. So we've got this library of pre-built Jenkins files or Jenkins pipelines that let you do this by just clicking a button. So I'm going to click a button. I'm going to pick this pipeline that uses testing, staging, and production environments with human approval to production. So I'm going to click that and click Next. Right. So now we've created the Git repository. We've associated a Jenkins pipeline with the project. And now you can see it's kicking off a build. Now, what we've tried to do, I should have maybe shrunk the screen resolution a bit, but never mind. What we've tried to do is unify all of the things you're going to need to look at into one screen. So we've been using Fabricate to fabricate for quite a while now. And in the early days, we found we're looking at Jenkins quite a bit, and we're looking at the Git repository quite a bit, and we're looking at Nexus quite a bit. And we're looking at all these different things all the time, and then we're looking in the environments. And we found we had so many tabs open, and we kept flicking, and you just kept getting really confused. So we've tried to put everything on one screen. So from this one screen, you'll see as the pipeline runs, we can see the pipeline running, we can see the logs. If I scroll down a little bit, we can see the logs flowing by. Just while that build's going, it'll take like maybe 1 minute. I'll show you the other apps we have. So if you click this little thing in the top right, we have the app switcher. Now, these are the first 3 apps you'll run, but over the lifetime of your journey in microservices, there's lots of other tools you probably want to use. I didn't show you this. Let me just show you. If you look at the runtime of your development tools and you click this run button, there's all these other microservices that are one click away that you can run. You might want to run GitLab, Grafana, Gerrit, SonarQube. You might want to run ChatOps with Slack or Let's Chat. There's Chaos Monkey, which is really, really funny, that kills your pods to check that your system recovers properly. We've got a whole raft of different services. And so over time, you can gradually add more and more of these tools to your pipeline and to your team, which adds you more capabilities, but then there's often a console you need to flick to, which is where this little menu comes in. So to start with, there's only a couple of things to look at, but over time, there's more and more things you can play with. Notice that the testing environment now has something running in it. So what we've done is we've generated the code, we've tagged everything with version 101 in Git, we've built everything, staged it to Nexus, generated a Docker image, tagged the Docker image with 101, pushed that into the Docker registry. We've now done a system test, which I'll explain later, but effectively is using Archillion to run a system test in the testing environment. Now that's gone green, so it looks like the test should pass soon. The system test is asserting that the thing you've built, the Kubernetes manifest and the Docker image and all that kind of stuff, does it deploy into the testing environment? Does it work? Yes, it did. It's gone green. So now the staging has kicked in. So now we've done a rollout into staging. If you notice, if you're colorblind, I apologize, but if you look very closely, it's blue right now and then it goes green. And this is the difference in Kubernetes. A container starts, but often Java takes a little while to really kind of get going. So blue is it's started, it's running, but it's not ready. And when it goes green, it's just gone green, so it's now ready, which means it's ready to serve traffic. So it's listening on HTTP and so on and so forth. All of the Fabricate tooling generates something called a liveness check and a readiness check in Kubernetes. A readiness check means, is it ready for traffic? In other words, should I include it in the load balancer? And it might be that your app might have to, on startup, connect to a database, connect to a message queue or something, preload a whole bunch of data so your cache is nice and warm. And it might take a few minutes before it's ready. So you can plug in your own custom readiness checks, which is really nice. So you don't hammer it with HTTP traffic until it's kind of warmed up. So we're now properly warmed up and everything, and we're green. And now I can actually invoke that service. So almost everything on this screen is clickable, so I can navigate around all of these kind of things. So if I click on that little link there, it's going to open the service that's running in the staging environment. And you can see the wonder of this amazing microservice that says hello world, which is pretty awesome. I'm sure that's adding real business value already. Anyways, but also all of these different links are clickable. So each of these environments are full logical clusters we can look inside and play around with, and they're all independent of each other. So if I click on say this button, I can look at the running containers in this environment. So I can see I've got my Malarkey that I ran an hour ago to check the internet was working, and I've got Devox Cool. So Devox Cool is the new container we just ran, and if I click on this little button, I can see it's been running for a minute. That's its IP address, that's its image, its IP address is there on the right, and if I click the logs button, I can look at the logs of this container and watch it work. So we can look at all of our environments, so we can dive in and see what's in there, and we can interact with all the services that are there, interact with the containers, we can scale up and scale down, and so on and so forth. Let me just pop back to the microservice console. By the way, we have two views. Sometimes a team will have multiple microservices. So this view is showing me all of the microservices in my team, and then each team has their own dashboard. So if I just want to look across all the microservices in my team, I can look at this view and I can see everything that's in testing and staging and production. You'll notice there's nothing in production yet. And then if I click on this view, now I'm looking at just one microservice. So if you're just developing on one microservice, you can zoom in and just look at one microservice, all the builds for one microservice, and all the environments for one microservice. Okay, and then from there, we can look at the Git commits and the versions and the docs and all that kind of stuff. Now what we're going to do is we're going to approve this release. So if I scroll down here, there's a button here to approve or proceed with the pipeline because we're waiting for human approval. And I clicked on that button and that was kind of okay as a microservices goes. So I'm going to say proceed. And now it should be deploying to production as well. So there, the production environment is spun at 101 in production. And now we've gone into production. Now that was quite a lot to take in. There was a lot of things on the screen. There was a lot of things to think about. But what we've basically just done is in a couple of clicks, created all the environments for a team, created a microservice, and we've taken a microservice, we've generated a basic system test, which I'll talk about later. So at least we know it runs and it stays up and it doesn't fail, and its liveness checks and its readiness checks are okay, which is like a minimal test. You should do more testing ideally, but at least we have a basic test that it can start up. Then we've moved it to the staging environment where you can have user acceptance testing or show it to people and we can play around with it. And then when you're happy, you can move it to production. So that was all completely automated with a couple of clicks, which is pretty cool. Let me briefly show you what happened under the covers, just so you kind of believe me and it's not all smoke and mirrors. Let's first off look at the Git repository. So if I look at the Git repository, this is it's kind of like GitHub. So here's the Git repository that was created. We can see there's a POM XML. This is a basic Spring Web MVC application. You can see it created a Jenkins file. So the Jenkins file is a file that's used to define your pipeline. It's a new part of Jenkins 2. And it's basically a groovy file, which is very groovy. So see that bin groovy? I don't know who wrote that stuff, but it's awesome, right? It's really awesome. So this is a groovy file. It's a groovy DSL for defining your build pods, right? So it allows us to say a pod is a Kubernetes term for a group of containers. So it allows us to pick what are all the software tools we want to use in our pipeline. So you might want to use Maven 303 or 339, let's say. Let's keep it real. Let's use Maven 339. Let's use a version of Selenium. You might want to use a version of Google Chrome browser for Selenium testing. You might want to use, I don't know, whatever tools you want to use, a Node.js image and so on and so forth. So you can pick all of the tools you want to use. You can define them in your Jenkins file. We can also do things like mounting persistent volumes. So we can say, I want to persistently store this build artifact forever because I want to keep some history between the builds. And then we can define in just this simple groovy syntax, we can define stages and steps and functions for how to do builds. Now, if you kind of read this, it's kind of readable. We're doing a Maven Canary release. We're doing a Maven integration test. Then we're applying the manifest into the staging environment. Then we're waiting for human approval. And then we're going to apply the production. Now, when we first started this, our Jenkins file was basically just command line stuff. We'd just be running Maven this, Maven that, Maven deploy, Maven set version, all those kind of stuff you do to do a release in Maven. And over time, we found that we had all these Jenkins files that were all kind of similar. So we started to refactor the Jenkins files into reusable functions. So there's this little magic thing at the top, @library. The @library lets you bring in a version of a library that has the reusable functions and steps inside. So over time, you can find that there's very similar blobs of Groovy that you want to share across your projects. I mean, what we found is pretty much anything that's Maven-based, the pipelines are kind of the same. I mean, you can obviously edit the pipeline on a per-project basis, but basically all of our pipelines are identical to each other. And if something changes, it's normally in the POM, it's not in the Jenkins file. So we really like the idea of having this reusable library of functions that anybody can use in the Jenkins file anywhere, and then have a reusable library of Jenkins files as well, so we don't all have to write Groovy. I mean, Groovy is groovy and it's fun, but you can go faster by just reusing it to start with, and then over time, tinker with it if you need to. So that's the Git repository. I'm browsing the source code and everything. Let me actually just do a quick edit to the code. So again, in this single pane of glass, you can actually browse the source code as well. So we can browse the source code and we can edit it. So you probably want to use like a real IDE like IntelliJ or Eclipse. No, I'm joking. So you might want to use an IDE of your choosing, and you might want to do a Git clone. If you go back to the Git repository and I look at the homepage, you can do a Git clone using this URL. So you can just Git clone it like GitHub, clone it to your laptop, then using IntelliJ, Eclipse, NetBeans, Atom, whatever you want to use, and then do a commit back, and then that will, if your commit merges to master, it will then do another release by default. what we're going to do is we're just going to edit the source code to show you what happens when you do an update. So I'm going to edit this, and I'm going to add loads of business value by saying something else. Awesome DevOps malarkey. And I'm going to hit save. So we've made a source code change. That's under the covers done a git commit. So if I now browse the git repository, if I click there and then click on commits, we should see I've just updated that. And if I view it, we'll see I've done this really awesome code change, which is fine. So we've changed Git, and because we automated the creation of the Git repository and the Jenkins build, we automatically added a webhook in the Git repository. So whenever you do a push of a change, it triggers the CD pipeline if it's on the master branch. So if I go back to the DevOps thing and scroll down, you'll see build 2 has started. So now it's going to go through the whole pipeline again. And it's going to release 102 to testing, and then 102 will then go to staging and then go to production with human approval. So we can see our entire flow is created for us. We don't have to think about it. We just click a few buttons and we're good to go. And if you really want, you can dive into the Jenkins pipeline and do things differently. You could fork our Jenkins pipeline library and write your own pipelines that do things differently. You could fork the Jenkins file library and do those differently if you wish. You can have your own. You might find that if you're a large organization, you might want a group that just look after the Jenkins stuff for you. So you have predefined pipelines for the canonical way of doing, say, I don't know, Java and Node.js or whatever, right? So it can help you. You can help all of your teams just get going quickly, so they don't all have to learn Jenkins, right? They can all just click a few buttons and go quickly. So while that's triggering away, that's just going to take a moment or two. Let me show you another couple of details. You've seen Gogs. I haven't shown you Jenkins yet. So this is Jenkins. We're using Jenkins 2. And you can see we've got 2 builds. So this is, if you haven't seen it, this is the new Jenkins Blue Ocean user interface. If all this is looking like too gorgeous for you, we can always show you the keeping it real, traditional, familiar and lovely Jenkins screen. So this is just normal Jenkins, right? This is the Jenkins we know and love. But then we've got like the new hipster Jenkins, which is like, ooh, color, buttons, nice. And then if you click on this one, oh, look, I can see all my pipeline stages. Look at that. I can see it go through all the stages, and I can see the log. It scrolls a bit crazily, mind you. But yes, so you can kind of view it in Jenkins if you wish and watch the beautiful colors and watch the errors when you make a mistake in nice red, which is nice. So that's Jenkins. It's just vanilla Jenkins, so you can always spin up your jobs in Jenkins as well. One thing about Jenkins, by the way, is so Jenkins pipeline is a whole new thing for Jenkins, and the basic idea is we should now add Jenkins files into our projects in the source code, right? So in your Git repository, put a Jenkins file in there, and then Jenkins knows how to build it, right? And that means you've then versioned your Jenkins build. I don't know if this has ever happened to you where somebody that you're not quite sure who makes a change in a build configuration and it stops working and you don't know who changed what, when, why. If it's in Git, you know exactly who changed it, so you can blame them. But more importantly, you can revert the change, or you can, at least you know what changed, right? So you can version your Jenkins files, which then makes it much easier. Remember, we're trying to go fast, right? So one team might want to change to the latest Maven and the latest Node.js, so they're racing really, really quickly. So they might be editing their Jenkins file really, really quickly. Other teams might want to stay on a really old, crusty Jenkins file, and that's fine because it works. So it lets each team go as quick as they need to go, right? Because we version everything in Git. Now, having things in Git is also kind of interesting because now Jenkins can find the Jenkins files. So there's a couple of plugins in Jenkins. One's called the GitHub Organization plugin, which you can point Jenkins to the GitHub organization. It works for GitHub Enterprise and GitHub Online. And it will iterate through all the repositories in that organization. And for every repository, it will iterate through every branch. And for every branch that has a Jenkins file, it spins up your Jenkins jobs. So the other way of importing projects is if you've already adopted Jenkins and you have Jenkins files, you can just get Jenkins to import your projects and then they all appear automatically on the Fabricate console. So that's Jenkins. One other thing which is not very interesting, notice by the way the testing worked. We've got 102 now in testing. We've staged to 102 and we haven't yet approved to production. I'll do that in one moment. I'm just going to show you something that's not quite as interesting, but it's important, is Nexus, that we've staged to the staging repository all these releases. So if I look in org example, I forgot to clear this out before the demo. What was it called? DevOps, cool. You can tell I've been doing a lot of demos there. So here's 101 and 102. So this is everything we released into Nexus. And if I look in 102, we've created a jar for the Spring stuff. We've got the POM XML. We've also got this thing, this Kubernetes YAML thing, which is basically the blob of YAML that you can just take and apply to any Kubernetes cluster. Now, if you're lucky, you can use this pipeline to go straight into production. It might be, though, sometimes different people have different rules about the production environment, like maybe developers can't see it or touch it or have any involvement in it. So it might be that the Jenkins pipeline might not be allowed to just apply the YAML file directly into the production Kubernetes cluster. So you might want to slightly modify your Jenkins file. So instead of actually applying it to the production environment, you take that YAML file and you maybe check it into a Git repository or do a pull request or email it to the ops people or something, so that then someone else in the ops team actually does the apply because they might want to review it or something. But hopefully we can all automate all of this stuff, right? We want to automate everything, right? So that's the Nexus part. Finally, let's approve this last release. Let me just find this approval button. My scrolling's gone a little bit odd on this little screen resolution. So I'll click proceed, and if I'm really quick, we'll be able to watch the running upgrade happen. So you see in the production box, the 102 starts up, then it scales down the 101. So we've done a running upgrade in production. I'll just wait for the green to happen, and then I'll show you it running in production. So in a few clicks, we've created a project. It's created the Git repository. It's created the source code. It's created the webhook. It's created the Jenkins pipeline. It's created all the environments for you for your team and for your microservice. It's done a release. We've actually done 2 releases now. Okay, we maybe need to work on our business value, but at least we've done 2 releases, so we've got 2 iterations down, and then we can maybe do a few more and get better. And then let's see, awesome DevOps malarkey. So we're making progress, right? We're getting faster. So that's the basic demo. I think that's about all I was going to show to start with. Let me talk about really what happens under the covers. So first of all, how do you do this, right? So now my demo's worked. You can now hammer the conference Wi-Fi and download the internet. So if you want to get started, go to this website. You can do this right now if you want. I'm sure the other presenters will hate me for saying this. Go to fabric8.io, fabric8.io, and if you scroll down a little bit, there's these 2 green buttons. The Install Locally button, if you click on that one, oh God, this robot thing. Let me go to one I downloaded earlier because I can't be bothered to do a robot. If I zoom up a bit, there's a link here to download a binary called Go Fabricate. It's a little binary. There's a binary for Windows, Linux, Mac. You download the binary for your platform and type Go Fabricate Start. And that's pretty much it. What that then does is it downloads a bunch of stuff that it says on that screen, but it downloads something called Minikube, which is a really cool little tool that will download Kubernetes, which I'll talk about in a minute, and build a single node cluster on your laptop. It'll then download something called kubectl. It's spelled kubectl, but the nice way of saying it is kubectl because that's friendly. So kubectl is the command line tool for interacting with Kubernetes. And then it will install Fabricate on top of that. So if you type Go Fabricate Start, you might need to go get a coffee because it will download a couple of Docker images, but it will start up reasonably quickly. And then you'll be able to do everything I just did right now, you'll be able to do on your laptop, right? If you want to do it, it's maybe easier just to start on a laptop, really, and then play around with it, get a feel for it, see if you want to play around with it for real. Then if you want to do it for real, then you're going to need a real Kubernetes cluster that's more than just a laptop. And then you probably, you might start with just installing it on the cloud, maybe Amazon, maybe Google, maybe Azure, maybe DigitalOcean. If you click on this button, oh God, you capture again. I cached it already. There's this. You go to this page. There's a website called stackpoint.io. This webpage kind of tells you all about it. And there's a little video as well. There's a website called Stackpoint that lets you type in which cloud you want, pick a couple of VM sizes and how many VMs you want, like Amazon. Type in your Amazon credentials, and it spins up a Kubernetes cluster for you in a couple of seconds. And then it will put Fabricate on top of it. It's got a lovely Fabricate button now, bless them. So in a couple of clicks, you can have a real production-grade Kubernetes cluster running on Amazon or Google or Azure with Fabricate all pre-installed for you. So it's really, really quick and easy to get going. So it's easy to get started, it honestly is. If you have any issues at all, we've got a feedback button on the website. You can get feedback either by raising an issue, chatting on Slack. You've got to do the Slack thing. We have to request an invite, and then we have to say, yes, come in. But that's a Slack thing. If anybody can figure out how to avoid that, please tell me. Or you can use IRC if you want to keep it real, like a proper geek. So that's how to get started. It's really, really quick. It's really easy. There is no configuration. As soon as you do go fabricate start, it will install Jenkins, Nexus, the Git repository, the console, and everything kind of works. All the secrets are wired up. I could cry if I thought about how much of my life I've wasted by configuring just Jenkins and Nexus to talk to each other. And then something happens in the Jenkins server, and then I have to start again, and then somebody craps on the Maven settings file, and you're like, everything just works. You don't have to touch it. You don't have to mess with it. Everything is beautifully predefined, right? So it's really, really awesome. So please try it. Have a play with it. See what you think. I just want to talk a little bit now about what is Fabricate, what's under the covers. I've kind of given a few hints already. The main three things of Fabricate are Docker, Kubernetes, and Jenkins. So very, very briefly, Docker is the way we should all be packaging our software now. Why should we be doing that? Because it's an easy way of automating the release of software, right? VMs are big and heavy and expensive because a VM has a complete operating system inside it as well. A Docker container is just your software, just that, in an immutable image that you can move between environments, and you can run multiple instances. I never actually showed you that. Let me just show you that, by the way. If we go to the production environment, and we're looking at our deployment, so here's our deployment of the DevOps tool. We can just click the scale button and run 3. And then now it's going to run 3 containers of that app. Notice they start blue, so we've got 2 blues and 1 green. And fairly soon they're all going to go green, and we'll have 3 greens, and then the load balancer will then go across all 3 of them, right? So it's really easy to scale up and down any of your microservices. You really want each microservice to be scaled independently because they're all going to use different I/O and CPU and whatever. Some microservices will be hammered with a gazillion HTTP requests. Some microservices might get 1 request a day, so you might not need many of them, right? So you want to be able to efficiently scale your microservices. If I click on this button, I can see all the individual containers that are running, and I can see all of their logs and so forth, right? So you can easily scale up and down. All right, let me go back to slides. There they are. Okay, so we use Docker to package things up into an immutable image you can just run. This is the command line in Docker to run something. If you have a Docker image, you just type Docker run, name of the image, and it just runs, right? So running Docker locally on your laptop is okay, but what you really want to do is run your containers in a cluster. So you've got a bunch of hardware. You can be scaling up or down your cluster on, say, Amazon, or plugging new machines in as you find new hardware. Your hardware might be growing or shrinking, and you want something that runs these containers across all of your hardware. And that's where this thing called Kubernetes comes in. How many people were in the Kubernetes talk that Ray did from Google earlier this week? Okay, awesome. So you probably know all about this now. I don't need to say too much, but there's quite a lot of hands that didn't go up, so I'll say a few words. Firstly, go watch Ray's videos. So whenever you get home and you've slept a bit, look at the videos online from DevOps and watch Ray from Google's Kubernetes talks. He did about 2 of them, and they're really, really good. And he goes through in detail what Kubernetes is. Basically, Kubernetes it came from Google. It's based on all the decade of experience of running containers at scale across lots and lots of hardware. And Kubernetes is really a thing. It's a little bit of software you install on every machine, and it turns the machines into a cluster, like a logical cloud or a mainframe, if you like. You could think of it as a distributed operating system of sorts. It turns your hardware into just a resource. You can just run containers on it. So this is the version of that Docker command line. kubectl run, you give it the name of the image, and you give it how many replicas to run. And if you say replicas 5, it makes sure there's always 5 instances of your microservices running forever. If one of your services crashes or core dumps, it will spin another container up. If the machine that was running one of your containers dies, it will spin another container up somewhere else. So it makes sure at all times it's got this kind of feedback loop where it's watching what's running on your hardware, and it makes sure there's always 5 running at all times, which is really, really nice. So Kubernetes really helps us run stuff, and it does all the load balancing and all those kind of things. There's a little diagram. We mentioned about Jenkins. So Jenkins, we now use the Jenkins file to define your continuous delivery pipeline. It's a nice groovy script. It's nice and simple, and you can use a groovy DSL, and then you can use functions and stuff to extend it and refactor it and make it simpler. And then we have two libraries. One is a library of Jenkins files, and one is a library of pipeline functions and steps. And you can use both of them together, or you could just use the pipeline steps if you wish, or you could fork it and just play around by yourselves and do your own things. But we'd like it if you, we love contributions. So if you ever write a new function that's cool, please just submit a pull request and pull it back so we can try and share this stuff across teams and companies. So that's the main things in Fabricate. We stand on the shoulders of lots of other open source giants. So I'll just mention a few of them. I can't really mention everything in Fabricate because there's a whole range of different tools and technologies that you can then slowly grow into. Start with Jenkins and Nexus and the Git hosting, and then gradually there's a lot of other things you can kind of play around with. The first thing to play around with, which I didn't run on my laptop because I don't have that much RAM, is centralized logging and centralized metrics. So you have to have centralized logging and metrics in production. I'd even recommend it in staging as well, really. I mean, why not in every environment, really? Disk is pretty cheap these days. So for centralized logging, we use a tool called Elasticsearch, which is open source, and is a kind of a scalable databasey thing for chucking blobs of YAML into it or JSON into it, and it will then index them so you can query them, right? So every log event, if you think Java util log, SLF4j, log4j, is that all the three? Yeah, all those things. All that Java stuff that logs stuff. We can capture all of those log statements. We can annotate them with what's the environment you're in, what's the team you're in, what's the application you're in, what's the version you're running. We can annotate those logs with more JSON stuff and chuck it all into Elasticsearch, and then we can search and sort it and stuff. So you can say, show me all of the logs in production in the last 10 minutes in my team, or in my microservice, or in this one pod of my microservice, this one container. So it lets you slice and dice and see what's going on, which is really, really nice. So Elasticsearch is the backend that stores the log events. The thing that collects the log events is something called FluentD. It's a small little binary that we run on every machine in the cluster. Kubernetes has something called a daemon set, and a daemon set lets you say, I want to run something on every machine, which is, you don't normally do this kind of stuff, but for management it's perfect. So you can kind of say, I want this management daemon, FluentD, to run every machine in your cluster. And then FluentD then just looks at all of the Docker containers running on that machine, captures all of their logs, and streams them all into Elasticsearch. So every container you run on Kubernetes, all the logs are captured. And it's not just that Java logs, it's any Docker image log. So your MongoDB, your Cassandra, well, like Cassandra's Java, MongoDB, your Eiffel randomness, RabbitMQ, Memcached, DNS, HAProxy, like any Docker container you run, including Kubernetes itself, all of the logs are captured and put in Elasticsearch, which is really, really awesome. Then you need a front end to query all this, right? There's a REST API, but there's a lovely user interface called Kibana. Again, everything in this presentation is open source, and you can just use it in Fabricate. Kibana is a HTML5 web app that talks to Elasticsearch that lets you do charting and graphs and explore data and browse around and find things. On the metrics side, metrics are a little bit different. Logging is all around blogs of key-value pairs that get stored in Elasticsearch for searching. Metrics are all about having a time series of a numeric value, right? So like the CPU of container 7 over the last week goes up and down over time. So metrics is all about capturing that chart of ranges of values for CPU load, disk, I/O, memory, whatever. There's various tools under the covers, but the main one is something called Prometheus, and Prometheus captures all of the metrics from every Docker container. Then Fabricate also then exposes all of the JMX metrics in every JVM. So any MBeans that are in your Spring Boot app or Wildfly Swarm app or whatever, all the metrics of all the MBeans get captured as well. So we have a store of every metric over time. And then there's a tool called Grafana that lets you view them and chart them and slice and dice them and so forth. So this is a quick example of a chart. This is a Kibana dashboard that shows you at a glance. The top row is all of the commits on all the different microservices. The next one is all the builds. The next one is all the actual rollouts or deployments. And the last one is various different donuts of things like logging and errors and so forth. I'm running out of time, so I'll speed up a little bit. This is a Grafana dashboard. Again, it's a simple out-of-the-box one, and you can define these dashboards to show whatever you want. We can do things like we can compare different technologies of microservice and see microservice 1 is really massive and using loads of RAM and CPU, and microservices 2 is really tiny and small. Maybe we should use that technology and not this one. So it lets you help understand the relative costs of your microservices, so you can iterate to reduce cost if some of your microservices are quite expensive, particularly when you start looking at things like databases or streaming or messaging or storage. Different options you could take have different financial implications, so the metrics help you figure out the financial stuff. You can also create your own dashboards based on whatever your key performance indicators are, like what are the metrics that really matter to your business. Like if you're an online retailer, how many orders per second am I taking, right? So you want a dashboard that's just got what is my orders per second over time, so you can see how is your business actually functioning, right? We have all the tiny little metrics for like CPU and whatnot, and we can aggregate them. But really what you want to do is start building dashboards that really tell you really how is your system performing for your customers. And Grafana and Prometheus can really help on that. So that's logging the metrics. And again, you just run this in the Fabricate console. If you have a slightly bigger box than mine, if you go onto the runtime, if you want logging and metrics, you just click run, and there's a button called management. Let me scroll down. There we go. We just click management, and we go run. I'm not going to run it because my bot can't quite cope with it. You just click run, and it will run that app, and now you've got logging and metrics enabled on your cluster, right? It's really, really simple. So that's logging and metrics. I would recommend highly always run logging and metrics all the time. You probably don't want to bother on your laptop because it might not cope. Another thing that's really interesting when you start doing this microservices journey is each team is then focused on one microservice, and you call out to other services without really knowing much about them, because you're very much focused on your microservice, right? Which is one of the good things about microservice. Each team is specialized and looking at one thing and knowing everything about this one microservice, which is good. The downside is you're calling all these other microservices that is changing all the time, and you have no clue what to do. So what often happens is you have timing issues where it used to be kind of fast, and now when I call this thing, it's suddenly gone really slow. Why? And there's this tool called Zipkin, based on the Open Zipkin standard, that lets you add little breadcrumbs into all of the network requests so that it can trace and visualize what service invocations are being made by your microservice. So you can get these kind of call graphs of what microservices are invoked, and most importantly, how long do those requests take, so you can see where's the hotspots. So it's a little bit like in the old days when we would all obsessively performance optimize your Java code, and we find what is the function that's taking all the time. Zipkin's kind of like that, but for a networked approach rather than for a single process. So that's Zipkin. And by the way, we have a one-click install of the Zipkin console and the Zipkin runtime. So if you want to enable Zipkin, you just run it as another microservice inside the Fabricate dashboard, and it just kind of works. You do have to add the Zipkin library to your Java code, though. Circuit breakers is another one another common and popular thing. Circuit breakers in general is a way, if your microservice is invoking something else, and that other thing could be slow or possibly even not there, you might not want to fail like a web request might be coming in from a user, and you're invoking some other service to help return something to the user. You might not want to hang forever because the user will think your website's not so good. So you might want to say, okay, I'll wait 2 seconds for a reply, and then I'll time out, and then I'll use some default fallback data. So if you want to render, say, purchase recommendations, if the recommendation engine is down, you can always have a fallback set of recommendations that you return as the fallback. So circuit breakers let you have like a fallback option if a service is down, and set a timeout. When something is down, this always confuses me, but the circuit breaker opens, which means it's not actually going to the backend system, it's just returning the default. Then over time it retries and eventually closes again, so you're back to using the backend system. So if one of your systems has a problem, you don't keep hammering it constantly with requests. You just leave it alone for a while, and then now and again ping it and see if it comes back. Because usually when there's a failure, the worst thing you can do with a system that's failing is give it loads of load. You kind of want to give it a little bit of a break and then go back slowly. Hystrix has a lovely dashboard, which again is a one-click thing to run it inside Fabricate, and it just boots up and it appears on your drop-down menu. And the Hystrix dashboard views all of the states of all the circuit breakers in all of your apps, which is really nice. We have Hystrix support in Vertex, in Apache Camel in Spring Boot and in Wildfly Swarm. So it doesn't really matter which technology choice you go with. They've pretty much all got Hystrix support in the box now, and then all of those Hystrix metrics are exposed into the Hystrix dashboard, which is kind of cool. So that's Hystrix. ChatOps. ChatOps is increasingly a very common way of microservices teams working together. I think lots of us all are increasingly using chat to work together. Now, the ideal thing is if you're a developer, you kind of could do with your own office with a door, right? Because then you don't get interrupted all the time, or you don't have to put your noise-cancelling headphones on and ignore everybody. But if not, so often people might be separate in separate rooms, or people might have all the headphones on so they can't hear anything. So chat is a really nice way of communicating, whether you're in the same room, different countries, different offices, whatever. What's interesting with microservices is because everything's changing so much, it's kind of good practice to have a room per team. And every time there's a new microservice created for that team, every time there's a new release, every time something goes bad with a release build, every time an approval is required, you can use the chat room. And we've got various chat bots that work with Slack, IRC, Jabber, HipChat, probably a couple of others that I've forgotten, Let's Chat, using something called HuBot that comes from GitHub. So we basically let you use whatever chat engine you wish, and then basically Fabricate can talk to you and you can talk to it. You can then trigger builds via chat, and you can do approvals of promotions through chat, which is kind of nice. So ChatOps kind of fun. Plus you get motivational squirrels, and that can't be a bad thing, can it really? How do you develop? I'm getting short on time, so I'm just going to briefly describe. So I've shown you Fabricate and how it will help you do continuous delivery, spin up projects, do the end-to-end thing, operate things. So we've seen the kind of big picture. How do you do the stuff before you commit, right? How do you hack code locally and then commit? So the first thing is if you're using Maven, we have a bunch of little tools that will help you take any Maven project you have right now and move them into Kubernetes and into Fabricate. So the first command line you see on the slide, by the way, the last slide of this has a link to these slides, so you can just download these on a phone or browser shortly. The first line of this is a little Maven plugin, which will add the Maven plugin into your POM, or you can copy and paste the blob of XML, whichever you prefer. Once you've enabled the Fabricate Maven plugin in your project, it's a small little bit of XML it adds. You can then use the Fabricate goals on your project to do various things. Now, if you haven't run Go Fabricate Start before, you can type the second line, and that will basically download Go Fabricate for you and do Go Fabricate Start. So that will create you a cluster that you can play with on your laptop. If you've already created a cluster, you don't need that step, but that's just there if you want to do everything through Maven. Then the third option, that compiles and runs your application. Let me see if I can even demo that. I might not have enough time, but I might try. If I can remember which shell I had open. Let's try this one. Yeah, okay, that's quite a big shell. Okay, let's do that. So I'm in a project here. If I quickly look at the project, we'll see I have a POM XML. This is just a off-the-shelf Spring XML WebMVC example. And if I make this a bit bigger and scroll, this is the stuff that the Maven Fabricate plugin added. So it's just a simple, straightforward Maven plugin. You'll see it's got an execution goal. So it's adding resource and build as part of the Maven lifecycle. And if I take Maven Fabricate Run, this is going to take a couple of moments, but what this is going to do is it's going to compile the code, make the jar, run the unit tests. It's going to generate the Docker image. It's going to push the image into the Kubernetes cluster. It's going to generate the Kubernetes manifest that defines what image to run, what environment variables, what the service is, which I'll talk about later. What's the liveness probe? What's the readiness probe? All that kind of stuff. And it's then going to run it, and it's actually running now. You see, it's running there. So that's a normal Spring application running. Now, the beautiful thing about this, and the thing I really like, is if you just showed this to a developer who knows nothing about Docker, nothing about Kubernetes, the developer thinks this is running on their Mac or their Windows box. This is actually really running in a container inside Kubernetes. What the Maven tooling is doing is just tailing the log of the thing that's running in the Docker container. So what I just typed there, Maven Fabricate Run, this is running that application in a container inside Kubernetes. What we've tried to do is make Kubernetes look and feel like an app server. So if ever you've used like Tomcat or Jetty or Wildfly or Spring Boot, you type Maven something :run, right? And it runs. The thing is that normally runs on your laptop, which is the worst place to run it. You want to run it in a production-like environment. So you want to run it in a Docker container inside Kubernetes. Okay. What's also kind of cool is if you Control-C, it stops. But it stops by scaling down the thing that's running in Kubernetes, because there's not really a process running on your Mac. It's a container in Kubernetes, which is really, really, really cool. Okay, my time's up. So I'm going to quickly fast forward to the last slide, which is the most important. There's where the slides are. Click that slide link and all the slides. There's a couple of bonus slides I didn't quite get to that you can see. And there's the fabricate.io webpage, which is how you download, fabricate, and get started. So basically, we all need to go faster. Download Fabricate. It's the best way we've figured out so far of going fast. Try it out, see what you think, and please give us feedback, because with feedback we can get better and we can make it better. And pull requests are even more awesome, but just any feedback at all is good. So thank you for coming and listening, and enjoy the rest of the conference. Thank you.